Please welcome to the stage Eclipse with Seth Winterroth.
How we doing? In the back. Excellent. Seth Winterroth, partner at Eclipse. We started Eclipse 10 years ago, if you can believe it, to back the early stage companies trying to reindustrialize the critical industries that operate in the physical world. It's fantastic to be at an event like this 10 years later with all of you that agree with that view and that need that we absolutely have to focus on. A core piece of our strategy from the earliest days was modern robotics. And this is an area that I've been building and investing in for the better part of the last 15 years. I'm excited to say that we're in the thick of a renaissance in modern robotics, and that's really been driven by three factors. Number one, converging technology capabilities that are making it possible for small teams to build solutions that can tackle complexity in environments that's orders of magnitude greater than what we could do 15 years ago. Number two, the talent density that's amassing in this space is just unprecedented. Best-in-class engineering, operations, sales, financial leadership from other industries is realizing the opportunity in this new computing revolution. And three, and most importantly, real work is being done reliably, performantly, and safely for customers. And so customers are seeing real IRR and ROI for their business operations. There is no company that embodies those three pillars more than Bedrock Robotics. I'm pleased to invite Boris Sofman to the stage to tell you all about it. Thank you.
All right. Thank you so much, Seth, and real pleasure to be here. Let's see, I'm gonna go back one here. Okay, perfect. Today's actually special. It's the first public announcement of our company, and we're really honored to do this at Reindustrialize. It's really almost a perfect event for this. We are working on automation, advanced autonomy for specialized heavy machinery, and we're starting with the equipment in the construction space. And so we'll talk a little bit about the mission behind this, what led us to it, and how we're approaching it, and why this is actually one of the most important potential unlocks for one of the big constraints for the US economy. As we look at this, we have an unprecedented need to build. We need housing units, we need infrastructure, energy, manufacturing. We have just infinite demand, hundreds of billions of dollars per year in manufacturing that's being driven by policy changes that are reindustrializing, huge housing shortages. Infrastructure is short by almost $4 trillion over the next 10 years. So the need is immense. And so just as the need is actually surging on the supply side, we're seeing labor become the limiting factor in what we can build. We have 500,000 open roles for construction in the country. That's increasing. Almost 40% of construction workers are retiring in the next 10 years. And you have an industry that, even all this aside, over the last 50 years, it's one of the only industries that has not actually increased in productivity in any meaningful way. And so you put all this together, you have an absolute crisis. When you have rising demand, really painful constraints on supply, prices go up, projects you need to get done get put off indefinitely, and everybody pays for it. Every industry, the government, every consumer, the entire economy starts to feel this. And so we are at a fork in the road, and the only answer is to use technology in order to address the supply side challenges in this industry, and autonomy is the answer. But it's not a simple autonomy problem. You have to not just navigate from point A to point B in a sterilized environment, you have to deal with super nuanced and complex kind of tasks and behaviors. You have to work around people and do this safely, and you have to be able to generalize and scale to very diverse machines. And so this is at its core a large-scale machine learning problem. And there's actually a lot of parallels to this problem to one that myself and a lot of our team at Bedrock actually spent a big portion of our careers focusing on, and that's autonomous driving. So we're at a point where technology is now able to handle these toughest problems, the holy grails of AI that really were these iconic challenges that people for a long time didn't know whether it would be possible to tackle. We're seeing this play out in transportation at Waymo. I was the executive at Waymo for about 5 years. I led the autonomous trucking program and a number of technology teams where we helped launch the Jaguars into San Francisco. And this is scaling really fast. This is actually at a date where, as of yesterday, Waymo announced it's 100 million fully driverless miles, so very timely. Scaling exponentially, it's 2 million miles a week at this point, and it's 5 times safer than a human, and this is only increasing over time. So these are superhuman levels of capability. And so when you look at the actual problem, it's infinite complexity. People, cars, cyclists, permutations of challenges that you could never engineer your way through. You have to treat this as a large-scale machine learning and data problem. And that was the real shift at Waymo that really unlocked this exponential growth 3-4 years ago. And so when we shipped the system, it didn't just solve the hardest problems in San Francisco, it actually generalized across cities, across platforms from car to truck. And data becomes the way you explain how to tackle new challenges and how to jump to new platforms. And that's a huge difference where now all of a sudden you can scale exponentially and get this flywheel where these jumps get easier and easier versus the inverse if you were trying to engineer the system using a traditional approach. And so we saw this incredible opportunity to apply these sort of technologies and capabilities to construction. You have an industry that's double-digit percentages of GDP. It's an enabler of almost every single sector in the economy, and it's struggling. It is genuinely struggling where every single general contractor you talk to cannot find the labor to do the jobs that are in front of them. And so I'll talk a little bit about how we do this. We are retrofitting existing machines with compute and sensor upfits. These cost a small fraction of the base cost of the machine, and it turns these machines, existing machines, into ones that are autonomy capable for the scope that they're cleared for. That scope increases over time with software updates, and it can still be driven manually when needed. And so our customers become the general contractors and subcontractors that are actually doing the work. And the product is the Bedrock operator. It's the operator and the software wrapped around it, and so now we are providing the labor and the flexibility to reinvent the operations of a modern general contractor. And so we're starting with excavators, which are the most common machine, and it's also one of the most difficult to learn. And so let me tell you a little bit about how this works. You have upfit, snaps onto a machine, you have sensors, cameras that can see all the way around the machine. You have mounts that go right into existing mount points, so it's fully reversible. This can be upfitted in less than 3 hours for a machine from start to finish. LiDAR gives you incredible precision on the environment, every detail of the terrain. You have dual GPSs, IMU, LTE modules, and then inside the machine, we have a compute that is a really high-end compute that integrates all the signals from both our sensors as well as everything coming through the machine, and that becomes the brain. And so now, you can do incredible things. You have 360-degree field of view, occlusion sensors for extra visibility, so perfect safety visibility, exactly like the architecture of a car truck, workflow camera, workflow LiDAR, so you have incredible precision in the areas you're actually working. You get this amazing data and environmental understanding, so now you can have all these extra benefits like insights on your progress, you can have real-time estimates on the completion of the job, complete precision on the amount of earth moved. And then you're able to train and use these large-scale machine learning models to actually operate autonomously. And this is trained from tens of thousands of hours of data, which is going to go towards hundreds of thousands of hours. And at the end of the day, there is no software on how you curl your bucket or software on how you interpret the world. Everything is learned. And the nuances down to the tiniest detail of how an operator might interact with the world can be captured. And so we have these now across almost 20 machines across 4 states. We have 4, actually 5 at this point, industry partners. And we're seeing data from jobs all across the country that are representative of all the types of work that we want to do. And this creates a pipeline of capabilities that will start to get absorbed into this operator. And so this is actually one of my favorite sites. It was one of the first active sites that we visited with one of our partners. It's an interstate expansion out of El Paso, and it represents what is actually a vision for where this goes. So you're digging down to level the ground. You got to over dig and backfill with the wheel loader. Motor grader spreads it, compactor compacts it to get a good base to be able to then build on. Took 2 months to excavate out this hole here. There's short and operators there always. And so for us, what starts as an excavator doing heavy earthwork, integrating into today's workflow, seamlessly working with other crews, as you start to run this flywheel and you jump to new capabilities and then you jump to a wheel loader, motor grader, compactor, bulldozer, scraper, you start to get 90, 95, 97, 98% subsidized in the amount of data you need and the amount of work you need. And in the end, when you fast forward a few years and you're controlling all these machines, you can up-level the whole experience, and now you have an operating system that is managing this entire fleet of machines. And as a GC, you're not micromanaging the wheel loader, you are defining a goal. Here's what I want, and it becomes a digitized manufacturing process in the real world. And so we're really excited about this, and we're at a point where the technology is proven. The economic need is absolutely urgent, and if we go all in on this opportunity and really tackle the supply side constraints, we can unlock a golden era of building in America. Thank you very much.